Hi, everybody. Welcome back to the self-check section 6.2 video. Let's go ahead and take a look at number four. So number four is talking about adult IQ scores that are normally distributed with a mean of 100 and standard deviation of 15. So let's go ahead and write that down. Mean 100 and standard deviation of 15. So part A is asking, find the probability that a randomly selected adult has an IQ score that is less than 120. So first thing we got to do is draw that distribution. So distribution, our mean is 100, and we want to know an IQ score that is less than 120. So 120 would be around over here above the 100, and I want to know less than that 120. So I'm going to shade to the left of 120. So here's what our distribution would look like. So let's go ahead and write out what our calculator would give us. So probability X is less than 120. That is our normal CDF, and it's our lower, upper, mean, and standard deviation. So here we're looking at 120 and everything below it. So when we're going below, we want to include that really low bound of negative 9999. So what we would have here is normal CDF of negative 999. Our shaded region is only going up to 120. So that would be our upper 120. And our mean is 100, and our standard deviation is 15. Okay, let's go ahead and put this in our calculator. So go to second vars. We're going to go to normal CDF, and let's go ahead and put in what we have written down on the paper. So negative 9999. 120s are upper bound, 100s are mean, and 15 is our standard deviation. Okay, so that's the value we get for the area or probability is 0.90878. Round that up to 8. So let's go ahead and write that down. So this comes out to 0.9088. And that tells me that this probability is 0.9088. Okay, let's move on to the next question. So what percentage of adults have IQ scores above 140? So above 140. So we're looking at something above that specific score. So let me, same thing, draw a distribution. Mean is still 100. We're looking at the value of 140, so it should be over here somewhere. And I'm looking at above 140, so that means I'm going to shade everything to the right of 140. That's what I want to find. Okay. So question mark, I want to figure out what the probability of the shaded region is. So let's set that up. So probability of X greater than 140, and that's normal CDF, and I'm looking at the shaded region right here. What's the lowest I can go? The lowest I'm going is 140. Okay, so 140, and the highest I'm going all the way over here to a really large number. So what I'm going to put for my upper limit is 9999. 9999, and then my mean and standard deviation are still going to be the same. Okay, so Now that we have all these components, let's go to our calculator and figure out what our probability is. So probability is second vars, normal CDF. My lower limit is 140. My upper limit is that really big number, 9999. And my mean and standard deviation are still the same. So once you have all that set up, you're just going to hit enter. And we get a very small number. We get 0.0038. Very small probability. And that makes sense because we just have a very small region right here. It's very small. So we're going to have a small area for a small probability. So my answer is 0.0038. And so we found that this area here is going to be 0.0038. Okay, let's move on to part C now. Still finding probability. And we want to find a probability of an IQ score between two values now, 95 and 105. So same thing, let's go ahead and draw our distribution. Here we have still the mean of 100, but now I have two values I am trying to find the probability between. So 95 and 105. So let's go ahead and shade these in. And so let's go ahead and write out our calculator work. So probability 95 less than X less than 105. That means the probability between. And this is going to be normal CDF. And I'm looking at the shaded region. What's the lowest I can go? That's going to be 95. And the highest I can go is 105. So here are my lower bound and upper bounds. And my mean and standard deviation are still the same. So once we throw this in our calculator, this would be second vars, normal CDF. 95 is our lower limit, 105 is our upper, and our mean and standard deviation are still the same. And we hit enter and we get our probability. So 0.2611. Okay, let's go back to our notes and write that out. 0.2611. So that's what this shaded region is. That's the probability, the area. It's 0.2611. Okay, so last part for this problem is Q3. So recall Q3 is the third quartile, but what that also means is the 75th percentile. So what we have here is a distribution of 100, and I'm trying to find the 75th percentile. So what that means is I need to find a cutoff value that gives me 75% of my data. Remember, percentile is below. So it's everything below this K value. That's our 75th percentile. So here what we have to do is use inverse norm. So K equals inverse norm. We put our area in there, so that would be 0.75, and our mean and standard deviation are once again the same. So let's jump to our calculator and get our third quartile. So calculates 84. We go to this second vars again. We're going to go to inverse norm. Inverse norm, and we're going to put in 0.75 and then our mean and our standard deviation. And what we get is 110.1. So that's our third quartile or 75th percentile. So let's go ahead and write that down. So 110.1. So this value right here is 110.1. And what this means is 110.1 is our 75th percentile. Okay, let's go ahead and look at the last question here of this self-check. So 5 is saying birth weights in Norway are normally distributed with a mean of 3,570 grams. So let's write that down. And a standard deviation of 500 grams. Okay. If the university hospital in Oslo requires a special treatment for newborn babies weighing less than 2,700 grams, what is the percentage of newborn babies requiring this special treatment? So they get special treatment if they weigh less than 2,700 grams. So what we want to do is find the probability that a newborn baby can weigh less than 2,700. So remember, percentage means probability. They mean the same exact terminology. So let's go and treat this as normal. Distribution, our mean is 3,570. And we're talking about a baby that weighs 2,700. So that value is going to be somewhere over here, 2,700. And we want to find probability of a baby weighing less than that. So I'm going to shade everything to the left. I want to find a probability of something less than 2,700. So let's set up how we find that probability. So probability of X less than 2,700, that equals normal CDF and remember, when we go all the way off to the left, we need a really big negative number. So that's going to be negative 999. So here, we negative 999. The highest we can go is 2,700. And so our upper limit is 2,700. Our mean is still 3,570. Let me move this over to make some room. And our standard deviation is 500. Okay, so now that we have our probability set up, let's jump to our calculator and figure this out. So same thing, second bars, normal CDF, negative 9,999, comma, 2,700, comma, 3,570, comma, 500. And what I get is 0.0409. It's a very small percentage or probability. So 0.0409. So that's our decimal, but it's asking for a percentage. So let's go ahead and convert this to a percentage. And what we would do is just move this over twice. So what I get here is 4.09%. So the probability that a newborn baby in Oslo, Norway, will weigh less than 2,700 and require the special treatment is 4%. Okay, but that's it for this 6.2 self-check. Thank you for watching. I'll see you next time. Goodbye.